IBM and AMD, well, they've announced a partnership to develop the next generation of computing architectures. IBM shares were up following the news that came out yesterday. Pleased to welcome to the show its VP of Quantum, Jay Gambetta. And the next generation of computing architecture is bringing together supercomputing and quantum. What does this partnership bring, Jay?
Yeah, this is, well, first, thanks for having me here. What's really exciting is we are actually getting to the point where quantum computers are getting to become like almost a first-class citizen in the future of computing.
Yeah.
And so this partnership is bringing AMD, which builds really high-performant, excellent GPUs, our leading quantum devices, and really starting to bring this fabric together. We want to create this future of computing that allows us to run things on quantum or run things on GPUs and really push computation to the next level.
So that hybrid approach, it almost makes me think of the new GPT-5 model in terms of they will use the right model for the right question. Is this kind of way you're doing it? If it can be solved with supercomputing, you go that way, otherwise it goes to quantum. How will this function?
That's exactly right. So a lot of people think quantum computers will replace classical computers. We've never had that view. We actually think quantum brings this unique ability to look at certain problems a little bit different. And now if you mix this and make it so that it works with HPC, AI, you really can start to bring many different forms of computing together and really advance what is possible.
Okay, so make it tangible for our audience, because they've always seen the promise of quantum. You're saying now it's a first-class citizen in perhaps driving forward medical use, thinking about the future of finance or algorithms. But what precisely do you think that this hybrid will offer?
So it's a great question, and we've got to get to the point where quantum is really getting us beyond what we can do with classical, which we think will happen in the next year or so, but we're getting at a point where it's allowing us to look at things in a different way. To give you an example, take a hard problem, I don't know, solving and designing drugs. You can spend a lot of money to model it, you can spend 10 years of research. Imagine a future where you could have AI scanning vast amounts of data, HPC or GPUs processing, crunching that data, and then quantum simulating the quantum physics at an accuracy we were never able to do before. Now you put all this together, you can start to imagine workflows that go beyond just AI or HPC or quantum and creating this, we call it quantum-centric supercomputing, but essentially this new fabric that allows you to do that. So what's quantum doing? It's giving you accuracy for problems that we didn't have that accuracy before.
I'm going to ask a sensitive question, but why AMD? Because NVIDIA's got quantum accelerated computing as well.
Honestly, we are creating this future, and anyone that shares a vision, and we're the same as us, that is towards this future that has quantum, working with classical, we're happy to partner with. So we've got this partnership with AMD that has got two parts of it. One is making our quantum computers better. The second is bringing these accelerators working to it. But as we go forward, we have partners with the national labs all around the world. But we want to show that this future is not just words, it's actually real. So anyone that shares the same view, we're happy to partner.
So Jensen could come and say, me too, please.
I'm happy to.
I'm interested in what the limiting factor is now, because it's often been about sort of fault-tolerant quantum computing. Is that what you need to get to? You sort of promised us that by 2029.
Yeah, so think of two sides of it. By 2029, we want to have a fault-tolerant quantum computer. And what we've learned through all the hard science and engineering is we need classical computers to make that possible. They got to do we call it decoding, but essentially removing the effects of errors. So part of this partnership is how do we actually use classical computers to make quantum computers better. And then at the same time, we really have to show the value of quantum computers, and we have to solve them for interesting problems. So now we need quantum computers working with classical computers in this quantum-centric supercomputing hybrid approach to really bring forward early applications so that we can actually start to see, for whether it's in finance, optimization, whether it's in simulating materials, we can start to see this value happen.
What's interesting is we like to sort of pit the generative AI landscape as a race. You're very committed to open source nature of this to try and build learning. How much is quantum a race? Where does the money end up coming in terms of for IBM?
So it is a race. We have to build hardware, and we've been a leaders at quantum hardware for a very long time. We're going as fast as we can do it. But you asked before, how do we get from having the hardware to value? You need smart people to discover algorithms. And then through discovering algorithms, you create use cases, you create examples. We are committed to open sourcing the tools for that algorithm discovery to happen as fast as possible, so that once we combine the hardware we build with that algorithm discovery, you really start to get those use cases. So think of the hardware as a race. We have to build as fast as we can the most performant quantum computers, and then we have to, at the same time, create an ecosystem that really focuses and discovers algorithms at a rate that we probably haven't seen since the 60s or 70s, of discovering new algorithms that use both classical and quantum.
Jay, it's been great speaking to you. You have a demonstration later this year. We'd love to get the update then. Jay Gambetta, IBM's VP of Quantum. Now, coming up, we're going to get back to what is, of course, the top name for tech investors, for every investor, actually, because it's the biggest company on the S&P 500, 8% of it, in fact, in terms of overall weighting. It is NVIDIA.